Good morning, everyone. We'll now continue our discussion in nuclear chemistry. So, konting slides na lang to and okay na tayo sa nuclear chemistry. And then, after this one, magpo-proceed na tayo sa next topic natin, which is fuel. So, next week, expect a long quiz since hindi tayo makakapag-quiz online. So, next week, magpo-quiz tayo. Lahat ng na-discuss natin this midterm. Wala pa kayong first quiz, wala pa kayong gaanong activity. Okay, kindly open your cameras first before tayo mag-proceed pala. Mag-open kayo ng camera. Wala pa yung iba, iilan pa lang kayo dito, bahala sila. Mag-open kayo ng camera. Okay. So, we are now here in radioactive decay series and half-life. So, let us define first the terms that we need to remember in this topic. So, we have what we call radioisotopes or radionuclides. So, this undergo nuclear decay in order to turn into a new atom, which is called a daughter nuclide. Okay, so we have mentioned that an isotope is tinatawag siyang radioisotopes if it is radioactive. Kapag radioactive siya, meaning to say, unstable siya. Kapag radioactive siya, siya ay unstable. Meaning to say, if a radioisotope or if an isotope is unstable, kakailanganin niyang mag-undergo ng process para maging stable siya. So, mag-undergo ngayon siya ng tinatawag nating radioactive decay. So, again, radioactive decay happens because naturally substances tends to go from unstable to stable state. Kaya nag-undergo sila ng radioactive decay. Bakit sila nag-undergo ng radioactive decay? They need to release excess energy for them to become stable. They need to release excess energy. So, ang tawag natin na dun sa new atom na mafo-form natin ay daughter nuclide. So, let's go back dun sa mga example natin na reaction before. Saan ba yung mga yan? So, dito. Etong radon 222, ito yung tinatawag natin na radioisotope or radionuclide. And yung daughter particle natin is etong polonium. Etong polonium-218. Ito yung new atom na mafo-form niya. Yun yung sinasabi ng definition natin. That is the daughter nuclide. If the daughter nuclide is stable or non-radioactive, the disintegration or decay will stop. So, kapag naging stable na yung daughter nuclide natin, magi-stop na yung radioactive decay process natin. But then, if the daughter nuclide is radioactive, then disintegration or decay process will continue until a stable final nuclide is produced. So, ibig sabihin yan, kapag yung radioisotope natin, di ba, we have the radioisotope. And then, magiging daughter nuclide siya. And if this daughter nuclide ay radioactive pa rin siya or madami pa rin siyang excess energy, mag-undergo ulit yan ng radioactive decay. And then, after undergoing radioactive decay, unstable pa rin siya or radioactive pa rin siya. So, mag-undergo ulit yan ng radioactive decay and so on hanggang sa maging stable siya. So, kapag stable na siya, dun lamang magi-stop ang radioactive decay process natin. That is why may tinatawag tayong radioactive decay series, a series of radioactive process hanggang sa maging stable siya. So, So, ayan, radioactive decay series is a natural process which produces several unstable nuclides with varying decay rates. The mode of decay an isotope will employ can be predicted based on the NP ratio of the radionuclide. So, we have discussed this already. Madedetermine daw natin kung anong type. Kung anong type or anong mode of decay. Is it alpha? Is it beta? Is it positron? Using the neutron-proton ratio. So, in radioactive decay, we have what we call the half-life. So, what is this half-life? So, from the term or from the word itself, half-life. So, tingnan natin kung ano bang ibig niyang sabihin. So, the half-life is the time it takes for an exactly one-half of an unstable nuclide to decay. So, eto daw yung time. Let's say, for example, yung radon 222 natin kanina, yung radon 222 natin. Let's say for example na ito yung radon 222 natin, parang chalk ang kaliit niya. So yung time na gagamitin mo or yung time na magugugol for that radon 222 para maging half siya ay tinatawag natin na half-life. And then yung time na magiging half ulit to is second half-life, and yung time na magiging half ulit to is yung third half-life niya. So, this one is the first half-life, this two is the second half-life, and this one is the third half-life. So, yun yung tinatawag natin na half-life. Different radionuclides have different half-lives as consequence of their different decay rates. So, ang iba't ibang mga radioisotopes, ang iba't ibang mga radioactive elements natin ay iba't iba yung half-life nila. May mga radioactive tayo or may mga radioisotopes tayo na mababa lang yung half-life, yung time niya or yung half-life niya. Yung iba 8 days, yung iba minutes lang or yung iba seconds lang. Pero may iba naman na it takes years. Let's say for example this one, itong carbon 14 natin. Bago, let's say ang carbon 14 natin is this one. So it takes 5,930. Supposed to be this is 5,730 Mali yung nandyan. 5,730 years muna ang gugugulin bago siya maging half. So, diba, napakatagal. While our iodine 131 it only takes 8 days. O, pati itong xenon 133 natin, it only takes 527 days para maging half siya. Para maging half the initial amount. So, some nuclides, sabi dyan, may have a very short half-life, as short as a fraction of a second, while some may have half-lives that can reach years, as shown in the table below. So, nakita naman natin dito, this is why the overall disintegration process from the parent radioactive nuclide to the stable daughter nuclide may take several years, sometimes to several centuries. So, several centuries, so hundreds of years muna bago maging half or bago magkaroon ng stable nuclide ang isang radioactive element. So, later on sa calculation natin, magagamit natin itong half-life natin sa calculation natin ng radioactive decay. Okay, so this one, let us try to use the concept of half-life para makuha natin kung ilan daw ang matitira after nitong third half-life natin. Okay, let's try. So, ang ating radon 226 daw has a half-life of 1,620 years. How many years will it take for 1 gram of radon 226 to be reduced to 25 gram? Okay. So, ang initial amount natin at t equals 0, we have ang amount ng ating radon is, let's denote radon as Ra. Ang amount niya is 1 gram. Why t equals 0? Kasi wala pa namang nangyayari. Yung initial amount natin is 0. Yung initial time natin is 0 and yung initial amount natin is 1. Ang sabi, ilang taon daw ang kakailanganin natin para maging 0.25 gram na lang yung matitira. So sabi diyan, ang half-life daw is 1,620. So we write it here. After 1,620, sabi natin, magiging half yung amount ng radioactive compound or element natin. So that would be 1,620, magiging 0.5 na lang to. Kasi nga hati siya. 1 divided by 2 is 0.5. And then, ang sabi dyan, 0.25 kasi ang kailangan natin. So, 0.5 pa lang to. So, hindi niya pa na-reach yung 0.25 gram. So, mag-undergo ulit siya ng another half-life. So, this is the first half-life and this is the second half-life. So, anong nangyayari dito is, meron na lang tayong 0.05. So, divided by 2 again, kasi sabi natin, diba, dun sa discussion natin, na this is the first half-life, nahati yung buo. And then, sa second half-life, mahahati ulit yung nahati natin kanina. So, that would be, ang mangyayari, magiging 0.25. Okay, so, eto yung sagot natin. How many years will it take for 1 gram of radon 226 to be reduced to 0.25? So, ilang years? 1,620 plus
400.
this would be
405.
0, 2, 6 plus 6 is 12, 3,000. 3,220 years. So, nagkaroon tayo ng dalawang half-life. So, meaning to say, nagkaroon tayo ng dalawang half-life. So, after 1,620 years, kinailangan mo ulit ng 1,620 years para ma-half ulit siya. So, that is 1,620 plus 1,620. That would be 3,220 years. And, ang tanong dyan sa next, how much remains after the third half-life? So, eto is the second half-life. So, magkakaroon ulit tayo ng third half-life. That would be 1,620 years ulit. So, that would be 0.25 divided by 2. 0.125, no? So, that would be 0.125 gram after third half-life. So, medyo ayusin lang natin to. So, sa second half-life, hindi na siya 1,620, 3,220 na siya. That is 3,220. And then,
Hindi ba 40 po?
ha?
3 to 40.
Okay, 3 to, oo pala. 3 to 40. And then, sa third half-life, 3 to 40 plus 1,620, that would be 0, 6, 8, 4, 8, 60. So, ganito ang nangyayari kapag mano-mano natin i-calculate yung half-life and the amount ng radioactive isotope natin. Pero we have an equation to use, a formula to use kapag isosolve natin yung time and amount of substance. So, dito, the amount of substance left after n half-lives can be computed by using this formula. So, yung kanina, yung tinatanong sa atin is, how much remains after the third half-life? So, that would be, pwede natin gamitin to, where yung N natin, yung NO natin, this one is the initial amount. And initial amount kasi 0 pa lang yung time natin. Yun yung ibig sabihin ng NO. Ang N naman is the amount of nuclide or isotope left after any time t. So, ito yung natira. NO is the initial and N is the remaining. Ito yung remaining amount. So, let's try to solve the previous example using this one. So, ang tinatanong sa atin dito, how much remains after the third half-life? So, that would be our N. Ang N natin dito is 3. Our N is 3 kasi third half-life ang tinatanong. N is the number of half-lives. And our N is 0.125. Ang ating initial amount is 1 gram. And then 1/2 raised to wait lang. Ano ba yung tinatanong sa atin? No. Control. Ito pala yung tinatanong sa atin, yung natira. Ito naman na yung sagot naman na yung nilalagay ko. This is N raised to 3. So, yung N na makakalculate na dapat natin dito is pareho lang dun sa nakalculate natin manually, which is 0.125. Kindly check, pareho lang ba?
Yes, ma'am.
Okay. So, ito yung formula. Kasi, what if ang tinanong sa atin sa previous example kanina is, how much remains after the 10th half-life? So, can you do that manually? Definitely, yes. Pwede pa rin naman. Pero, magko-compute ka mano-mano ng 4, 5, 6, 7, 8, and so on kapag 10th na yung tinanong. So, this one is more convenient. Magagamit mo agad siya. Plug and solve lang siya. So long as you know the formula or the equation. Next is half-life computation. So, the disintegration decay of an isotope follows a first-order equation. So, yung sinasabi nating first-order equation is, ang equation natin dito is negative dn all over dt is equal to k n. So, simplifying, this will be our equation. So, ito ang gagamitin natin na formula to calculate the original amount of nuclide and the remaining amount of nuclide. So, this N stands for, nasabi na natin kanina, amount of nuclide, and NO is the original amount. And K here is the decay constant. So, magkakaiba kasi ang decay constant natin. This is the reason why magkakaiba ang decay constant natin. This is the reason why magkakaiba din ang half-life natin. So, you see, may mga half-life na mabilis lang, may mga half-life din na sobrang tagal. Kasi magkakaiba yung decay constant natin. So, this decay constant ang nagde-dictate kung ano ang magiging half-life natin. So, the formula for half-life kanina, this one, the formula for half-life is T1 half ln 2 over K. So, you just need to remember this. Kapag ang tinanong is, what is the half-life of this one? So, kapag given ang decay constant natin, makakalculate natin ang half-life natin. Okay, let's have an example. So far, nakakasunod naman. Nakakasunod. Okay, let's try to apply the formula. The half-life of a sample is 8, this should be 8.1. The half-life of a sample is 8.1 days. So the half-life is 8.1. How long will it take for 3/4 of the sample to decay? So, ilan daw ang time na kakailanganin natin para mag-decay ang substance natin para mawala ang 3/4? So, sometimes, yung mga problem natin is hindi agad-agad yung binibigay is yung exact value. So, in this example, how long will it take for 3/4 of the sample to decay? Ibig sabihin, kapag 3/4, this is 0.75. Ito daw yung nawala. And take note kanina na ang N natin dito is yung natira. Dapat reading comprehension. You know naman kung anong ibig sabihin ng decay, 'di ba? Nag-decay, ito yung nag-decompose, ito yung nawala, ito yung nawala na, ito yung nasira na, ganyan, ito yung decayed matter. Ito yung nawala. So, reading comprehension, guys, etong 0.75 dito, this is not the N natin. So, kapag mga gantong problem and walang given na initial amount, mag-assume kayo ng initial amount natin is 1 gram. So, this is the basis ha. Kapag walang given na initial amount, i-assume nyo na 1 gram or 10 gram or kahit naman ilan. So, 1 gram na lang para mas simple na lang. So, 1 gram and then tong 0.75 dito, this is not the remaining amount kasi ito daw yung nawala. So, ibig sabihin kung ito yung nawala and meron tayong initial amount na 1 gram and ang nawala is 0.75, so that would be 1 minus 0.75. So, it is 0.25. So, ito yung natira or ito yung remains after nag-decay ng 0.75. So, plugging in the value dun sa equation natin. So, this is our working equation, this one. So, that would be ln N over NO is equal to negative KT. But then, take note guys, na ang tinatanong sa atin is, how long will it take? So, etong time ang tinatanong sa atin dito. Given na tayo ng half-life, pero hindi natin alam kung ano yung decay constant natin. Ito yung tinatanong sa atin pero hindi natin alam kung ano itong value ng K natin. But then we have an equation naman kanina relating half-life and K. So we have here T1 half is equal to ln 2 over K or 0.693 over K. So pwede nating makalculate yung amount ng decay constant or yung value ng decay constant natin using our half-life equation. So, T1 half is equal to 0.693 all over K. So, given naman tayo ng half-life natin which is 8.1 days. That is equal to 8.1. So, calculating our K, K is equal to 0.693 all over 8.1. So, mapupunta sa kabila yung K, bababa yung 8.1 natin dito. So, this is our decay constant. So, that would be, plugging in our value, ln, the initial amount is 1 gram all over, our remaining amount is 0.25 is equal to Our K now is 0.693 all over 8.1 negative to times T. So, calculating our T, T is equal to, anong magiging value ng T natin? Ano ang value ng T natin, mamanaw? Mamanaw, is mamanaw with us?
16.2, ma'am.
16.2 days. So, dalawang equation lang naman ang gagamitin natin. This one and this one. Yung half-life natin. Half-life equation natin. So, let's try to solve it. Yung mano-mano, yung ginawa natin kanina. So, at T is equal to 0, ang amount ng substance natin it's at T equals 0, we have 1. At 8.1 days, we have 0.5. At second half-life, 16.2 days, we have 0.25. So, eto na. So, ang matitira kasi is 0.25. So, dito tayo. So, it makes sense. Pareho lang yung masosolve natin dito. So, kapag nakalimutan nyo yung formula, pwede nyo gawin to. Basta hindi naman ganun kahaba yung tinatanong na process. So, pwede nyo gawin to. Etong manual na pag-solve ng half-life natin or ng time natin, ng remaining amount natin, pwede nyo gamitin to. But better na i-memorize nyo na lang yung equation natin, dalawa lang naman. So, nandito yung mga common application ng ating mga radioisotope. So, kapag ang radioisotope natin is carbon 14. So, ginagamit siya sa carbon dating. So, 'di ba kapag yung mga substances natin, kapag sobrang tagal na yung mga fossil fuel, ganyan, ang mga ano bang tawag doon sa mga nag-aaral ng mga ano tawag doon? Nade-determine pa rin nila kung ilang taon na yung object na yan. Halimbawa, yung isang babae na namatay doon sa snow, doon sa place na sobrang lamig, tapos nahanap nila, and then madedetermine nila kung ilang years na bang nandun yung katawan na yon. That is because we have the carbon 14 and it is used in carbon dating or determining kung ilang taon na yung mga bagay-bagay na may na carbon. So, we also have the uranium 238 dating. So, ang uranium 238 dating naman, siya yung nagde-determine kung ilang years na yung uranium or yung lead natin. Sa uranium 235 naman, this is used in nuclear power generation. So, ito yung radioactive or radioisotope na ginagamit nila to generate energy sa mga nuclear power plant natin. We have the hydrogen 3. Ang hydrogen 3 is ginagamit natin to determine the water content of the body. So, kapag dehydrated ka, 'di ba, nalalaman nila kung ilang percent lang yung nasa katawan mo, kung gaano ka ka-dehydrated, kasi meron tayong H3 or hydrogen 3. We also have the cobalt 60. This cobalt 60 is used for cancer treatment. We also have the iodine 131. Ito namang iodine 131. Nadadiagnose naman ito yung mga thyroid defects natin. And we have the thallium 201. This is for heart scan. So nalalaman nila if you have heart disease because of this thallium 201. And lastly, we have the technetium 99. So ito naman, ini-scan niya ang ating mga brain, liver, kidney, and kidney scans. So these are the applications of radioisotopes. And that's all for nuclear chemistry. Yun lang ang kailangan nating matandaan sa nuclear chemistry natin. So do you have any question? Dito, sa ano natin kanina, do you have any question here? So, isa na lang ang binigay kong example dito kasi ano lang naman, plug and solve lang to guys. Plug and solve. As long as you know kung ano na tong mga dinedenote ng mga variable natin dito. Ang N natin is the initial amount and O is the remaining amount. Remaining amount to ha, dito lang kayo magkakamali kapag nakalimutan nyo. Remaining is different from decayed. Kapag ang sinabi dito is, how long will it take how long will it take bago maging 3/4 lang? How long will it take for our sample to become 3/4? Kapag yun ang sinabi, edi ibig sabihin, yung remain natin is 0.75. Pero ang tinatanong kasi sa atin is how long will it take for a sample to decay? For 3/4 of a sample to decay. So iba yung word na decay and iba yung word na remains. So dito kayo magkakamali kapag hindi nyo naintindihan gaano yung problem natin. But aside from that, okay naman na madali na lang isolve basta alam nyo yung formula nyo. So, for our next meeting, ang i-discuss na natin is about fuel. The fuel will be our last topic sa under energy, and then after that, after fuel, magpo-proceed na tayo sa reporting natin, which is i-group ko kayo para kayo naman ang magsalita, no? So if no more questions, that would be all for today.